All right, here's the idea. Okay, here's a game plan for today. You have something like this, right? What's the degree of this polynomial? What do you think?
Degree 4.
Yeah, exactly. How can you tell?
There's 3 turning points.
All right, there's 3 turning points, but then that doesn't necessarily mean it's degree 4, but for our purpose, it's degree 4. It could be degree 6, it could be degree 8, yeah?
Mm-hmm.
The max is 3 turning points. Anyways, degree 4, right? Let's say this is -2. Let's say this is -1. Let's say this is, let's use different numbers, 3. Let's say this is 4, okay? Now the question is going to be, what is the equation of this guy in factored form, right? In factored form. And how does it work? Same idea for any polynomials. Let's say we have a quadratic, right? We have a quadratic. Let's say this is -1, this is 2, okay? And let's say we know the y-intercept is -8 or something. It's going to be in this form, okay? Look at this, y equals, all right? Y equals a x minus some number, right? X minus t, x minus s, x minus t. Let's do it in this form, where s and t are the x-intercepts, right? Look at this. It's very, very simple. A, it's going to become x minus s. So it's going to be x minus -1, right? X minus -1 becomes x plus 1 in this bracket. And then x minus t, well, t is 2. So it's just going to be x minus 2. We're not quite done yet because we need the leading coefficient, right? We need the a value. How do we find the a value? Well, simply plug in the y-intercept or any point that they've given you. At the y-intercept, the x value is going to be what?
0.
What is 0? Exactly right. Yeah, 0. So all you have to do is plug x as 0. Okay, plug x as 0. So 0 plus 1 is still a 1. 0. What's 0 minus 2?
-2.
Right, like this, -2, and then y value was -8. What's 1 times -2? Well, that's just -2. A -2 equals -8. What's a gonna be? What do we do on both sides? It's a very simple linear equation.
You divide by -2.
Exactly. What's -8 over -2?
+4.
Oh, yeah, exactly. And that's all. Easy as that, right? So therefore, the equation of this quadratic is going to be y equals +4, x plus 1, x minus 2. You see that?
Mm-hmm.
The same idea applies to any type of polynomial, right? If it's a cubic polynomial, we'll just add one extra bracket here. Like in this case, this is going to be a quartic degree 4 polynomial. So we're going to add 2 different brackets, okay? Let's say this is -5 or something like that. So we're going to have, again, these letters are whatever, like they're not important. What comes after T? U, and then we have V. You can call this whatever. You can call this alpha, beta. That's not important, right? That's just arbitrary letters. But what it does mean is there's going to be 4 different x-intercepts. Now look at this, y equals a, and we're going to do x minus -2, so that's going to become x plus 2. X minus -1 becomes x plus 1. X minus 3, well, that's just x minus 3, and then x minus 4. You see that? How do we find the a value? The y-intercept. So -5 is our y-intercept, and again, the goal is x is going to be 0, right? 0 plus 2 is 2, 0 plus 1 is 1, -3, -4. Tell me what this is. 2 times 1 times -3 times -4.
-24.
Right, 4 times 3 is 12. The negatives cancel out. So we have a times 24 equals -5. What do we do on both sides?
You divide by 24.
Exactly. So that's going to give us our a value, which is negative. And we knew it was always going to be negative because it was going upside down, right? That makes sense? Let's take this up a notch, right? If you understand this, you're also going to understand the next part. So let's look at this polynomial, okay? Let's look at this one. Something like that. What do you think the degree is of this guy?
Degree 3.
So this one, I've tricked you. It is not degree 3, right? Here's a new idea. We kind of briefly talked about this yesterday. If there's a turning point, right? This is gonna be a squared, okay? It's gonna be, let's just call it x minus s squared. You need to put a squared there because it's a mini parabola, yeah? You see this one? That is a mini cubic function. If you zoom in on it, it's gonna look something like this. You see, it's a mini cubic function. So that's a triple root. That is a triple root, like that. There we go. It's a degree 5 polynomial. If it's a turning point, you need to put a square. If there's like this cubic thing going on, then you got to put a cube. Compare this with something like this, right? See here, that's a linear, right? That's a linear, that's a straight line there. If you zoom in on that specific point, that's a straight line there, that's a straight line here. All of these they're all one roots, singular roots. Okay? I'm having like a storm here. I don't know what's going on. Oh my God. Hopefully it doesn't rain inside. It's very interesting weather. Is it raining there?
It's really sunny here.
Oh wow, there's like a storm, which looks really cool, but I wouldn't want to be outside right now. So that's the main ideas, okay? Degree 2 for a turning point, degree 3 for like a mini cubic function there, okay? Let's do this one. Okay, here we go. I'm gonna give you a hint. This is a cubic function there. That's a turning point. What is the degree of this function? Okay, first of all, is it gonna be odd or even degree? Look at the end behaviors, right?
It's gonna be odd.
No, it's not. It's gonna be even. How do you know? Because odd functions, they have different end behaviors, right? See, this is going negative infinity here. Why? Whereas that one's going positive. If they both go in the same direction, it's an even degree polynomial, okay? If they have the same end behaviors like it does, like here, as x goes to negative infinity, you see here's negative infinity. As x goes to negative infinity, where's y going?
Also negative.
Yeah. What about on the other side? As x goes to positive infinity, where's y going?
Positive.
Is this going to positive infinity on the y?
Oh, negative.
Negative. You see, the end behaviors are the same. That means it's an even function, okay? Now the question was, what's the degree of this function? Any ideas? It is going to be a degree 6. Okay, how can you tell? You see from this mini cubic, you get 3, right? It's gonna be like, let's say that's -1. Okay, that root is -1. So it becomes x plus 1 cubed. Let's say this root is +2. And again, turning point means what? It's a double root, right? Turning point means a double root. By double, I mean a square here. And then finally, this one is just a straight line. So that's a singular root. So it's gonna be x minus 3, right? So from this, you can pull out an x3. From that, you can pull out an x squared. Last one, x1. You see x cubed times x squared times x1 is x6. It is a degree 6 polynomial. That makes sense?
Yep.
Alrighty, let's jump into some questions. It's fun. I mean, it's not that bad. We did this question yesterday. Oh, and another thing, right? Another thing where we have to work backwards, okay? So let's say you're given a function like this, x minus 2, 2x minus 6. Can you tell me where the zeros are of this? Well, what's the degree of this polynomial? First of all, what's the degree?
2.
Yeah, good. It's degree 2. Is the leading coefficient positive or negative?
Positive.
Right, it's 2. The leading coefficient is also 2, right? So it's a parabola that opens upwards. Where are the zeros of this guy? There's 2 zeros.
Do I just flip the signs?
Right. So if there's nothing here, you flip the signs, right? But what you're technically doing is you're setting them both individually equals to 0.
Mm-hmm.
So what is x here? If you want to solve for x, what's x gonna be? Here,
Just 2.
just 2. What about on the other side? What's x gonna be?
Positive 3.
Exactly. So that's the zeros. The zeros are right there, okay? But then
Uh-huh.
you have to work backwards sometimes. Like let's say x is equals to 5 over 4, right? How do we work backwards? By backwards, I mean on the right side, we want a 0. Okay? On the right side, we want a 0. We need like something x minus something or plus something equals 0. We need it to be in this form. So what you do is step 1, you multiply by 4 on both sides. You see that? You get
Mm-hmm.
4x equals 5. And then what do? Subtract 5 on both sides. So you get 4x minus 5 equals 0. And there we go. That's our expression.
Okay.
So we have to be able to go from this to this, or vice versa, the other way around, backwards, from this to this. Cool?
Mm-hmm.
And then we're going to use this idea in the bigger picture here. We may have done this yesterday, but let's just quickly recap on how to do this. Write the equation of a cubic function that has zeros -2. And again, very simple, right? It's going to be a x minus s, x minus t, but then this fraction is going to give us something x minus something, okay? Look at this. What's s? S is -2, okay? So what does this bracket turn into? Replace that s with -2.
X plus 2.
Right. What about the x minus t? What does that turn into?
X minus 3.
X minus 3. But the third one is trickier, right? The third one is trickier. Let's work backwards with that one. X equals 2 over 5. What do we do first? We want to,
Multiply 5.
yeah, 5x equals 2. And then?
Subtract 2.
Exactly. So we get 5x minus 2. There we go. And now finally, we need to find the a value. They've given us the y-intercept, right? So simply replace y with the y-intercept of 6 and replace x with zeros. 0 plus 2 is a 2. 0 minus 3 is -3. 5 times 0 minus 2 is -2. See that?
Mm-hmm.
And look at this. This is also, you can do this in your head. -3 times -2 is +6. +6 times 2 is 12. So you have 8 times 12 equals 6. A is going to be 6 over 12, which is 1 over 2 or 0.5. Therefore, the equation is going to be 1 over 2. Final answer, it's going to be this guy. Okay?
Okay.
We also did this yesterday. Let's just quickly recap. You see there's a turning point on the 2x intercepts, right? There's a turning point right there. So it's going to be in this form. A, there's always going to be an A. That's the leading coefficient. Well, not technically, because if you have something like 5x minus 3 in here, then you got to multiply this with this to get the leading coefficient. But A does determine the sign, if it's opening up or down, right? So we have x, you see this -2 becomes +2, right? And the fact that there's a turning point there means this is going to become a square. Can you tell me what's the other bracket? Use the other x-intercept.
X minus 3 to the power of 2.
Exactly, it's a double root, right? Because there's a turning point. If there was like a mini cubic function here going downwards, then this would be cubed, okay? It's not, doesn't apply to this question, but we will see questions like those in the very near future. And in this one, they have not given us the y-intercept, but they've given us a point. It's the same idea, right? If they give you the y-intercept, then you just plug x as 0. They've given us this point. Y is going to be 4, the y value, and the x value is going to be 2. You see, 2 plus 2 squared, 2 minus 3 squared. 2 plus 2 is 4. 4 squared is 16. 2 minus 3 is -1. What's -1 squared?
+1.
Exactly. So we have a times 16 times 1 equals 4. So a is going to be 4 divided by 16, which reduces to 1 over 4. Therefore, our equation is simply y equals 1 over 4, and then there we go. Easy as that. Domain and
Okay.
range. The domain of any polynomial function, doesn't matter if it's odd, even, whatever. It's going to be from -infinity to +infinity. Domain represents the set of x values it can take, right? So if you drag this thing all the way to the left, you see it can take any x value. But this one is restricted on the range. If it's an even function, even degree function, sorry, it's restricted on the range. What's the range of this guy? Range means the possible y values it can take.
Um, 0.
0 to what?
+infinity.
There we go. Range is going to be this. But if this was an odd degree, then the range would also be -infinity to +infinity. Okay.
Mm-hmm.
Okay, here we go. Sketch the graph of this function. Is this in factored form? Factored form means there's going to be brackets. This is not in factored form. To sketch a graph, we need 3 things. Well, let's see. We definitely need the zeros. Okay. We need the leading coefficient, so we know it's going up or down. And then finally, we also need the y-intercept. Let's do this one by one. How do you find the y-intercept? What is 0? What's going to be 0 at the y-intercept?
X.
X, right? So you just replace, you just find f of 0. Y-intercept is just simply f of 0. Just set x as 0. So 0 to the power of 4 plus 2 times 0 to the power of 3. What is this going to be?
Just 0.
It's just 0, exactly. So we know it goes through the origin, right? Because when the x value is 0, the y value is 0. So it's going to go through the origin. Is the leading coefficient positive or negative?
Positive.
Positive, so it's going to open upwards. It's a degree 4 polynomial. Now finally, we need to find the zeros. To find the zeros, we always have to take it into factored form, okay? Think about this.
Uh-huh.
We can GCF out something here. By GCF, I mean you can pull out something. Both of these terms have something in common that we can pull out.
An X.
Not just an X. GCF means the largest number, the greatest number of things you can pull out. What do both of them have in common? They both have an X, but you can go a level deeper. They both have an x cubed, right? X cubed fits
Oh.
into 2x cubed. X cubed also fits into x4. So we need to take out the biggest thing we can take out, x cubed. But take out x cubed. By take out, I mean you're dividing, okay? What are we left with in the bracket?
Um,
What is x4 over x cubed? We've done this, right? This is just exponent laws.
just X.
Just x, exactly. What's 2x cubed over x cubed?
2X.
Just 2, okay? Because the x cubes cancels out.
Oh, okay.
There we go. Now that's in factored form. See, can you tell me where the zeros are for this guy? It has 2 zeros. It's easier than I think. To find the zeros, just set them individually equals to x, 0 here. 0 means for what value of x is the y value 0, right? Like that. X plus 2 equals 0, that means x is minus 2. That's one of the zeros. What about here? If x cubed is 0, what's x? How do you get rid of this cubed? We need to do
Square
something.
root.
Not square root, cube root.
Cube root.
What's the cube root of 0?
Um,
0. Okay.
Okay.
Square root of 0 is a 0, cube 10th root of 0 is 0, anything. 0 to the power of 10 is 0, 0 to the power of 3 is 0. 0 is a very nice number. Whatever you do to it, you get a 0 back. Cool?
Mm-hmm.
Now let's finally put up all the pieces of the puzzle. What do we know? We know it goes through the origin. So that's the origin right there. You see, look at this 0. What's this 0's root?
1.
No, it's 3, right? X cubed. You see that? We got a
Uh-huh.
0 from this term, right? We got a 0 from this term. That means this guy has a triple root. Okay?
Mm-hmm.
And triple root, what does that mean? There's going to be a mini cubic function there. Triple root means a cubic function. It's going to go like either like this or the other way. It's going to go like that at that x-intercept or at that 0. What's the root of the other term? -2. How many roots does that have? Just one.
1.
Just one. So at -2, it's going to cross like a straight line, but at 0, it's going to become a cubic function. Now let's draw this guy. So we know it's a positive quartic function. Positive quartic function starts in quadrant 2, ends in quadrant 1. At -2, it's just going to cross it like a normal, like a straight line, okay? But at 0, it's going to turn itself into a mini cubic function, and there we go. That's the sketch.
Okay.
Does that make sense?
Mm-hmm.
Let's say it was x minus 3 cubed, right? X minus 3 cubed. Then that means at +3, there's going to be a mini cubic function because the cube means triple root. You see that?
Uh-huh.
A bunch of words. But this is where this is used, by the way. You see, this is going to be an application, real life application question. We can model the dolphin's path using a quartic function. You see this?
Mm-hmm.
Quick question to you here. Is height negative relevant in this problem? Does it make sense for the height to be negative?
Yes.
Yes, it does, because the guy is going to go underwater, right? The dolphin is going to
Mm-hmm.
go underwater, so it does make sense. Now we need to come up with an equation, right? We need to come up with an equation. We know this looks like it's a degree 4. So where are the zeros? Can you tell me where the zeros are? There's one right there. What's that value there? On the x-axis.
2.
2. So what does it become? X minus 2, right? The next one is at 6. So x minus 6. The next one is at 10, right?
10.
X minus 10. What's the last one? Last one is right there.
14.
14. All 4 of these zeros have how many roots? 1, right? Because they're not turning,
Mm-hmm.
they're just crossing. If it crosses, it's 1 root, okay?
Okay.
They're all to the power of 1. And then finally, we need to find the a value. I'm gonna cheat here because I don't know what that is. Let's see what they say that is. Yeah, they're just using an arbitrary number, I guess. They're saying when x is 3.5, y is 0.5. Yeah, I don't know. I don't know where they got that. Does it say anywhere? That could be true, right? I mean, when x is 3.5, that's, I don't know, that's kind of dumb. Yeah, so they've guessed this point. You see that point? Could be anything though. That's not very scientific. But I guess we can use what they used. Usually they will give it to you, right? They'll give you like this point, or they will give you the y-intercept or something. So we know when the y value, when the x value is 3.5, the y value is a 0.5. So you have 0.5 equals, what's 3.5 minus 2?
1.5.
Yeah, 1.5. 3.5 minus 6 is negative 2.5. 3.5 minus this is negative 6.5. 3.5 minus this is negative 11.5, like that. So for this one, we definitely need a calculator. So 1.5 times negative 2.5 times negative 6.5 times negative 11.5. That gives me some giant number. So A times negative 280.3125. Then we're going to divide both sides by that number, 0.5 divided by that. So I got A is negative 8 over 4485. Replace that with that number, and we are one and done. Okay?
Okay.
And that's how you solve something like this. So here's the idea. If it crosses, right, you see at negative 2 it's just crossing, it's going to become x plus 2, then it's going to become to the power of 1 because it's just simply crossing it. But if there's a turning point, as you can see here, at the circle, right, at the circle there's a turning point. If there's a turning point, then it has a degree 2, okay? It has a root of 2. This x-intercept of 3, negative 3, sorry, which becomes x plus 3 up here, squared, because it's a turning point. And then if there's like a mini cubic function, as you can see here at the negative 3, which becomes plus 3, then it's a cubed, okay?
Uh-huh.
Good so far?
Mm-hmm.
All right, let's go. Let's keep this up. All right, match this with that. Let's look at graph A. What's the degree?
4.
4, right? Degrees 4. So which one of, is it B, A, B, C, or D? Which one fits the bill? Degree 4, and the leading coefficient is positive because it's opening upwards. What do you think between A, B, C, and D? Look at the zeros. What's the root of the zeros here? It's a turning point, right?
Uh-huh.
Turning point means what root? How many roots does that zero have?
2.
2, right? So at negative 1, it's squared, and at positive 3 it's squared, so it becomes x plus 1 squared and x minus 3 squared. You see, it must be B.
Mm-hmm.
So this one is out, okay? All right, what about graph B? You got this, you got this. Which equation makes sense for graph B? And again, notice there's a turning point, which means one of the zeros has a double root. So which one is it, A, C, or D? Could it be A? Look at A. What's the leading coefficient here, positive or negative?
Positive.
Does B have a positive or negative leading coefficient?
Oh, negative.
Negative, right? So it can't be A. Can it be C?
Yes.
Yes, it can, and indeed it's C, right? Because at 3 there's a double root, which becomes x minus 3 squared, and at 1, at negative 1, which becomes x plus 1, it has a single root. The negative 2 in the front also makes sense because it's going down, okay? So graph B is option C. What about graph C? Okay, now it's a 50-50, you can just guess. For C, is it A
It's
or D?
A.
Yeah, absolutely it's A, because leading coefficient positive. At negative 1, there's a double root, and then it's going upwards. So must be A. That means by the power of elimination, D is D. And that also makes sense because all the roots, all the zeros here, they have single root, right? They're just crossing. They're not turning. There's no turning point there. It says write the equation of each function. Let's look at A. What's the degree of A?
3.
3, right? Are there any double, triple roots?
No.
No. Very simple. Y is equals to A This is -3, it's going to become x plus 3. That's +2, it's going to become x minus 2. That's +5, it becomes x minus 5. How do we find the a value?
Your given point.
Yeah, exactly. So you're going to plug y as 8, and you're going to plug x as 1. 1 plus 3 is 4. 1 minus 2 is -1. 1 minus 5 is -4, like that. So you get 4 times 1 times -4 is 16. 8 times 16 equals 8. Divide both sides by 8. A is going to be 1/2, or 0.5. So therefore, the equation of the first guy is 1/2 and all of this. Cool?
Uh-huh.
Let's look at B. Tell me, how do we do B? What's the degree for B?
4.
Any double roots?
Yes.
Okay, where's the double root at?
-1.
Right, so it becomes, what does it become? It gets
Positive.
+1, and then what goes up
2 power
here?
3.
To the power of 2, right? Double root to the power of 2. And the next x-intercept is at 2, so it becomes x minus 2, and that's a single root. And then we're going to plug -12 as y. I'm going to plug 1 as x. So 1 plus 1 is 2. 2 squared is a 4. And then 1 minus 2 is -1, like that. So a is 3, okay? And there you go. That's the equation for question B. It's pretty straightforward once you get the idea, I guess. See the word order here? That is what what we mean by root, okay? Order 2 means that there's a double root there. Let's do this one by one. Sketch an example of a cubic function with the following zeros. Should be pretty straightforward. They have not asked us up or down, doesn't matter. There's a root at -3, a 0. There's a 0 at 0, and then there's a 0 at 2. Cubic function, boom, easy as that for the first one. See that? We can also go upside down. They have not mentioned which one, but we could absolutely go upside down as well for A. Let's look at B. How many zeros does the cubic function have for this one? There's 2 zeros. There's 1 at -1. Then there's 1 at 4, right? But you see this order 2 means there's a double root at 4, okay? So it's gonna, again, you can either make this positive, it's gonna go up, but double root always means a turning point. Boom. You can either do that, or you could also do upside down like this, and boom. One and done, okay? Order 2, order 3 doesn't matter, as long as you know there's gonna be a turning point or something. All right, we're gonna do a quick exercise, cause why not? I'm gonna give you the conditions. So it's basically gonna be what we did yesterday, okay? It's basically gonna be what we did yesterday. I'm gonna give you the conditions, and now you're gonna draw because you're the boss. Sounds good? How do I clear the page? Because erasing it is not gonna be very fun, but whatever. Maybe I can open another page. Oh yeah, I can just empty it. All right, there we go. That's way better than having to erase everything. So these are the conditions for you, okay? You're sketching a quartic function. Quartic function. Condition 1. You have zeros at -2, at 3/4, at 5, but 5 has a, what's going on? 5 has an order of 2. It's not letting me right there, but 5 has an order of 2. This thing is not very good, is it? Do you understand the question? So there's a quartic function, and it has a 0 at -2, at 3/4, and at 5, but the fifth root, okay, why is that not? The fifth root has order 2. Try drawing this. The fifth root, the root, the 0 at 5, this one, it has order 2. Are you able
Could
to draw
you
it?
write something? Because I can't see
You
anything.
can't see anything? Can you not see
It's
this?
just blank.
Let me retry. Okay. Can you see anything here? On the whiteboard?
Oh, now I can.
No, you can. Okay, cool. So, can you see this?
Mm-hmm.
All right, so again, I'm gonna give you the conditions and you're gonna draw it, okay? So there's a quartic function, quartic. It has 3 zeros. It has a 0 at -2, it has a 0 at 3/4, and it has a 0 at 5, but this 0 at 5, it has an order of 2. That means it has a double root, okay? Order 2 means double root. Try drawing this.
What do you mean by quartic?
Quartic means degree 4,
Oh, okay.
right? Cubic means degree 3, quartic, and then quintic is 5. Quartic means degree 4.
Could you do the first one?
Yeah, sure. So -2, again, wherever you see the zeros, right? Just so negative, there's a 0. 3/4. What's 3/4 as a decimal?
Um,
0.75, okay? 0.75. So let's just say that's 0.75 or 3/4, and then there's a 5. Yeah, good.
uh-huh.
Quartic means what? Again, let's just do opening upwards. It's gonna start here and there. You can also do it opening downwards, but let's do opening upwards. Okay, that's step 2. Step 1, write down the zeros. Step 2, just end behaviors. Where do you start? Where do you end? Finally, just connect the dots. At -2, there's a single root. At 3/4, there's a single root. How many roots are there at 5?
2.
Double root, right? What does double root mean? Boom. And you're done.
Okay.
Okay, easy as that. Nothing fancy going on here. Let me just erase this and we can open a new page. Okay, here's a new question. Again, it's quartic, okay? Again, it's quartic. There's a 0 at -1, but this one has order 3. And then there's a 0 at 2, which is order 1. Try this.
But what exactly does order 3 look like?
Order 3 cubic. At -1, there's gonna be a mini cubic function. It's gonna look like this. At -1, right? At -1, it's gonna look something like that. I mean to do this as well? Here, look at this. -1, there's a 0. 2, there's a 0. Quartic opens here, ends there, right?
Uh-huh.
And look at this. Order 3 just means there's gonna be a cubic function. Boom, like that. A mini cubic function. And then just connect the dots and you're done. See, if you zoom in here, you're gonna get a mini cubic function. That's what order 3 means. Order 2 means like a quadratic. If you zoom in there, it doesn't apply, but then there's gonna be a turning point there.
Mm-hmm.
Okay, so this one, you're gonna have to find yourself what the degree is. At -2, there is order 3. At 1, there is order 2. And then at 0, there is just one order, I guess. You don't have to mention that, right? What's the degree of this function?
Um, 6.
Yeah, good, 6. Try drawing it. We're gonna assume the leading coefficient is positive. In degree 6, degree 4, degree 2, all of them start on quadrant 2 and end in quadrant 1.
Um,
What happened? I don't see anything.
did I do that?
Okay, so what did you miss? You missed the 0, right? It has to pass through
Oh,
0, right? Try again. Yeah, that's kind of right, but you missed the 0.
like that?
Yeah, like that. But this one it's not apparent that there's a cubic function here. It should look something like this. Like if I zoom in here, right? There needs to be like mini cubic function. Okay?
Okay.
Like here it just looks like it's crossing it. That would be order 1, right? But we need an order 3, so
Uh-huh.
kind of exaggerate there. All right, I'm gonna give you the y-intercept. It has a y-intercept at 5, or yeah, at 5. Can you tell me what's the equation of this function? To find the equation, write it down in factored form, flip the signs, give them their orders, and plug x as 0, y as 5. How do we find the equation? Any ideas? No? Here, let me give you a hint, right? I don't see anything, so y equals, well, that's really thin. It's gonna be in this form, right? Y equals a, there's always gonna be an a, yeah?
Uh-huh.
What does the -2 turn into? The -2 turns into a plus 2, right? Order 3 means a cubed, like that. The 1 turns into a -1. Order 2 means squared. And the 0 is just x minus 0, or simply x, like that. Okay?
Mm-hmm.
Now y-intercept is 5, so the y value is 5 when the x value is 0. So 2 cubed is 8. -1 squared is just 1, right?
Uh-huh.
And well, this question is not gonna make sense. Yeah, you can't have a 0 on the x, but whatever. Let's just say that turns out to be a 1 as well. It's a moot question, but there we go. 5 over 8, and replace this with here. And you're done. 1 and done.
Okay.
Okay, let's go back to the other screen. It's kind of fun, right? It's fun too. I mean, if you get it right, it's fun, I guess. Okay, determine the quadratic function that has zeros at -3, -5, and f of 7 is -720. What does this actually mean? F of 7 is -720. It means when the x value is 7, The y value is negative 720. This is just a way for them to give you a point, okay? And now negative 3 becomes what? Y equals a. Negative 3 becomes x plus 3. Negative 5 becomes x plus 5. When the y value is negative 720, the x value is 7. So 7 plus 3 is a 10. 7 plus 5 is a 15. There we go. So a times 150 equals negative 720. So what's 72 divided by 15? 72 divided by 15, that is 4.8. And so there we go. A is negative 4.8. Therefore, the equation is negative 4.8 times x plus 3, x plus 5.
Okay.
Do you understand this?
Mm-hmm.
You tell me, how do we set this one up? Now it's a cubic. Same thing as before. Last was a quadratic. This one is a cubic.
Um, so you write y is 28?
No. So f of 5, that means when the x value is 5, y value is 28, right? Like that?
Mm-hmm.
That's a point, right? What do you start with? You start with a and then brackets. What goes in these brackets?
X plus 2,
Yeah,
and then x minus 3,
yeah.
and x minus 4.
Right. And now in this step, you write y as 28 and you replace x with a 5, right? 5 plus 2 is a
Mm-hmm.
7. 5 minus 3 is a 2. 5 minus 4 is a 1. 7 times 2 times 1 is 14. So you have a times 14 equals 28. Therefore, a is 2. Therefore, the equation is y equals 2, x plus 2, x minus 3, yada yada, x minus 4. Finally, it's a 10-second answer. Okay?
Mm-hmm.
Is this difficult?
No.
How do we, okay, we're gonna go back to the whiteboard thing because it's fun. Can you see this? Let me know if you see this writing.
Yes.
Okay, good. There's zeros at -1, which is order 2. There's a 0 at 3/4, which is order 3. And there's a 0 at 4. And then I'm also going to give you the y-intercept. The y-intercept is at 8. Find me the equation of the polynomial using this information. You always start off with y equals a, and then brackets, okay? Try this, see if you can. Okay, you also need to pay attention to the orders. Yeah,
For the 3/4, do I turn it into a decimal?
no you don't. What do? You have to work backwards for the 3/4. It's not gonna be x minus 0.75. No, that's wrong. You have to work backwards. It's gonna be something x minus something. That's perfect.
And then
The
what do I
y-intercept is
do?
8. The y-intercept is 8, right? So you replace y with 8, and you replace x with zeros to find the a value.
Okay. Wait, so do I keep the A though?
Yeah, you keep the A. That's the idea. You're gonna end up solving for A. It's gonna become a linear equation. So 8 equals A, and then 0 plus 1 is just 1. 1 squared is just 1. So that becomes a 1 there. So 4 times 0 minus 3, that's negative 3 cubed, which is negative 27. So this one, yeah, the second one turns into negative 27. And then the last one is just negative 4. So negative 27 times negative 4 is 108. So therefore A is 8 divided by 108, which reduces to 8 divided by 108, which is 2 over 27. Therefore the equation is 2 over 27, and then whatever you wrote there, 4x minus 3 cubed, x minus 4. All right, next thing. Why don't you try graphing this? You have everything you need. The leading coefficient was positive, okay? So A is 2 over 27. And this one had cube. Try graphing this. You don't really need this anymore. So first draw the grid, and then draw where the x-intercepts are and where the y-intercept is, and then just connect the dots.
So do I have to like make the line go through 8 as well?
Yeah, 8 on the y-axis. Which will be somewhere on the y-axis. Somewhere here, right? Somewhere here. That's 8. Now we know this is a degree 6 positive polynomial. Now connect the dots. Degree 6 positive means starts in quadrant 2, ends in quadrant 1. Yeah,
Is
that's
that
perfect.
kind of
That's perfect. Yeah, that's good. That's good. Okay, see, it's not that bad, right? It's honestly not that bad. So now let's go back to what else have they got for us. I'm not gonna do this just yet. Where's the mid-chapter review? All right, here we go. This is what I want to do. Which one looks difficult? I guess we can just do this. Okay, if the value of k is unknown, which means the leading coefficient, okay? You see that k in the front? We called it a, they called it k. Again, letters are arbitrary. Which of the following characteristics cannot be determined? Can we determine the x-intercept here? We just don't have the leading coefficient. What do you think? Can we find the x-intercepts?
Yes.
Yeah, we don't need the leading coefficient. The x-intercepts are at negative 14, positive 13, negative 15, and positive 16. Okay, we can definitely find the x-intercepts. What about the shape of the graph near each 0?
Also yes.
Also, yes, exactly. They're all degree 1s, right? Sorry, root 1s. So they're just gonna cross, nothing fancy going on. The end behaviors. Could we find that? without having the leading coefficient?
No.
No, you can't. We don't know if it's gonna opening up or opening down, right? So we cannot find the end behaviors. What about the maximum number of turning points?
You can.
Yeah, exactly. How many max turning points in this case?
3.
Exactly. So the only thing we can't find if we don't know the leading coefficient is the end behaviors, which means is it opening up or is it opening down? So determine the equation of the polynomial that passes through this point 7, 5,000 and has these x-intercepts. What is the degree of this function?
It's 4.
You're right. And then it passes through some point 7, 5,000, okay?
Mm-hmm.
So it looks like it's, is the leading coefficient positive or negative? It has to pass through that 7, 5,000.
It's positive.
Exactly, it's positive. And then now it's just a matter of connecting the dots. At -3, there's order 2. That means there's a turning point, right?
Mm-hmm.
At 2, it's order 1. That means it just crosses it. At 5, it's order 1 as well, so it just crosses it. Nothing fancy, and then it has to pass through that point. There we go. And that is the equation of this quartic polynomial. Cool?
Uh-huh.
What do you think about this unit?
I kind of understand it more now.
Right, it's fun, right? There's not a whole lot of math. It's just it's very logical, right? Even the calculator bits are very simple, and most of the equations turns out to be, well, so far anyways, they always end up being a linear equation, which is good. When we're trying to find the a value, it always turns into a linear equation, which is good. All right, let's call it a day there.
All right. Thank you.
Bye bye.